Hello, my name is Mr. Asprey and this is number 51. This is IGCSE. Edexcel, cones and spheres. Let's do it. So we've got a metal cube which has side lengths of 125 millimeters, correct to three significant figures. And then the cube is melted down and the metal is used to make solid spheres. And the volume of each sphere is 140 centimeters cubed to the nearest 10 centimeters cubed. Okay, work out the greatest number of spheres. Okay, so the number of spheres, let's call it n, will be the total volume of the cube divided by how much the sphere's volumes will take up. Now, if we want to maximize the number of spheres that we make, we're going to want to maximize the amount of volume from the cube, and then we want to make the actual spheres as small as possible to fit more, to make more of them. Okay, so the volume of the cube. Now, the upper bound of this to three significant figures is going to be 125.5 millimeters. Now that's the upper bound to three significant figures. I'm going to want that in centimeters because the spheres are in centimeters. Let's just convert that over by dividing through by 10. So that's how many centimeters it is. So to work out the volume, I just do this value cubed, because a cube is just its length times its width times its depth. And each of those are 12.55. Okay, and then the sphere, the volume of a sphere is given to you. It's 4/3 times pi times, oh, hold up. You don't need to know what the volume of the sphere is because you've already told what it is. It's 144, correct to the nearest 10 centimeters. So the lower bound of that will be 135 centimeters cubed. Because that's the smallest number, which when rounded to the nearest 10 goes to 140. So that's just 135. Okay, so we can just do this calculation, and that should give us the upper bound number of spheres. Okay, let's just do this quickly. 135, and we get 14.6. Now we can only make whole numbers of these spheres, so the correct answer is n is equal to 14. Perfect. Here we have a hemisphere on top of a cylinder, and it says that the hemisphere and cylinder both have a radius of 6 centimeters, fine, and the height of the cylinder is 10 centimeters, that's all on the diagram. The water is up to a depth of t centimeters inside the cylinder, and the volume of water in the container is half the total volume of the container. Okay, so we need to find the total volume of the container first. So the cylinder part, the volume of the cylinder part is pi times r squared times by height. That's given the volume of a cylinder. So this is pi times by the radius, which is 6 squared, times by the height, which is 10. So this will be 36 times 10, so this will be 360 pi. Okay, now we need to work out the volume of the hemisphere. Well, the volume of a sphere is 4/3 times pi times r cubed. Again, that's given. But if it's a hemisphere, then it's half of that. So we could divide this by 2, which just gives us 2/3 rather than 4/3. Okay, so this is 2/3 times pi times by 6 cubed. And this is going to be, don't think I can do that in my head. Okay, I think it's 144. I'm going to go over 144. Anyway, 6 cubed times 2/3 is 144. Should have backed myself. Okay, So the total volume, of course, is those two added together, which will be 360 pi plus 144 pi, which will be 504 pi. Okay, perfect. Now it says that the water is half of the total volume. So the volume of the water is going to be half of this divided by 2, which is going to be 252 pi. Perfect. Now the volume of the water is also a cylinder. And the formula for the cylinder, well, the volume we know is this, and the volume of a cylinder is pi times r squared times by the height. And in this case, it's going to be pi times by 6 squared, and the height we don't know, it's t. Okay, so in order to find t, we just need to divide both sides of this equation, first by pi. We can do that nice and easily, like that. And then we need to divide both sides by 6 squared. So t will be 252 over 6 squared, or 36. So 252 over 6 squared, and it's going to be 7, perfect. And that is centimetres, and that is Bosch. Okay, next question looks pretty horrid. We've got a solid made from a cylinder and a hemisphere again, and we know that the radius is x, and we know that the height of the cylinder is 3x. And then it just says that the total surface area is equal to 81 pi. Fine. So let's work out the surface area. The first thing I'm going to find is just the surface area of the base there. So that's just a circle. So that surface area will just be pi r squared, which in this case is pi times by x squared, because the radius of this shape is x. Okay. And now we're going to work out the curved surface area of the cylinder. So if you were to unwrap this curved surface area, it would create a rectangle. Just like when you unwrap like a can of beans, if you take the label off the can of beans, you're going to get a rectangle which wraps all the way around the shape. And the height of that label will be 3x. Now, the width of that label is all the way around the circle, like that. So it's the circumference of the circle. And the circumference of the circle is 2 pi r, which in this case r is x. So the curved surface area of the cylinder is equal to these two things multiplied together, which is going to give us 6 pi x squared. Okay, and then we need to find the surface area of the hemisphere, and the surface area of a full sphere is pi r squared, but we're going to have to half that because it's a hemisphere. So this is going to give us 2 pi r squared, and remember r again is x, so 2 pi x squared. Okay, great, so we've got this, and we've got this. So adding those together is going to give us the total surface area of this shape. So it's pi x squared plus 6 pi x squared plus 2 pi x squared, which is the total of 9 pi x squared. Okay, and we're told that that's equal to 81 pi. Beautiful. So we can divide through by pi. We can divide through by 9 on both sides. And then we can take the square root, so we get x is equal to 3. And obviously it has to be positive because it's a distance, so it can't be minus 3. Okay, fine. That's got us somewhere, but not anywhere near an answer. So the next thing we need to do is work out the volume. And I know that because we are comparing densities. And density is linked via mass and volume. And we know the mass. So the formula that links those three things together is a little triangle, I remember, with M on top and then D and V here. So if I wanted to work out the density, which I need so I can compare and figure out what shape it, what metal it is, I cover the density and I do mass divided by the volume. So to find the volume, once again it's the volume of the cylinder we'll do first, which is pi times r squared times h, which in this case is pi times by x squared, but we know x is free. I'll just write it out like this though, it's times by x squared, and it's times by the height, which is 3x. So this is altogether 3 pi times by x cubed. And if we know that x is 3, then x cubed is 27, times by 3 is 81. So it's 81 pi is the volume of the cylinder. But we also need to find the volume of the hemisphere as well to add that on. And the volume of a hemisphere, well, a whole sphere is 4 thirds pi cubed. So a hemisphere is half of that, so it's 2 thirds pi r cubed. And once again, r is x, and x is 3, so x cubed is 27, divided by 3 is 9, times by 2 is 18. So that's 18 pi. So the total volume is equal to, add these two things together, this and this, 81 pi plus 18 pi gives us 99 pi. Okay. And then we need to work out the density, don't we? Gosh, this question just doesn't end. Okay, so we've got the volume, but we now need to find the density. And the density is equal to the mass. Just double check it's in the correct units. Grams, centimeters cubed. Grams and centimeters cubed is the volume, so that's good. So it's 840 over 99 pi. So we put that in our calculator, and I'm really hoping this is going to give me something similar to what is on the chart. 2.7, oh, beautiful. Okay, so therefore our final answer is, and that's grams per centimeters cubed, aluminium. Or aluminum, if you're in the States. Cool. A cone has a volume of blah 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 pi centimeters cubed. The radius of the base is okay, fine. Let's just draw a cone to get started with. We draw ourselves a cone. It looks a bit like that. And it says that the radius of the base of the cone is equal to twice the height of the cone. So that means the radius of the base is equal to twice the height. So the radius of the base is 2 times bigger than the height. So let's call the height h. I always find it easier to label the smaller thing. And then the radius is 2h, because the radius of the base is equal to 2 times the height of the cone. So r is equal to 2 times the height of the cone, so r is equal to 2h. Yes, that works. Always worth double checking that, because so easy to make mistakes with the wording there. Definitely worth just double checking to make sure you've got it the right way around. Work out the curved surface area of the cone. Right, so let's look at the volume first. So the volume of a cone, as given in the formula booklet, is 1/3 pi r squared h. Still blows my mind that it's a third of the actual cylinder prism. But hey, that's a story for another day. A third times pi times the radius, and this is where we've got to be super careful. The radius squared is this squared, so I'm going to put it in brackets and square it like this, and then times by the height. So this is 1/3 pi, and when I square this, it gives me 4h squared, and then times that by h. So overall we get 4/3 pi h cubed. Okay, and we're told, we know what this volume is equal to. It's equal to 562.5 pi. Perfect. Pi's can go from both sides. So we can take that value of 562.5 and we can divide it by 4/3. So divide by 4/3 on both sides. And we get that, which is lovely because that looks really cube rootable. I believe that is 15/2, isn't it? Let's just double check that. Nice. 15/2. So that's the height. And it says work out the curved surface area of the cone. Well, that is given in the formula booklet as well. The curved surface area is equal to pi RL. And L is this distance here. It's the slanted height. So we're going to have to use a bit of Pythagoras on that. But let's just update our diagram first, because we know h is 15/2 or 7.5. So 2h is 2 times that, so that's 15. Okay, so now we could do some Pythagoras to find out L. It's going to be the square root of, because it's the hypotenuse, 7.5 squared plus 15 squared. So we could do that. So 7.5 squared plus 15 squared. Okay, fine. Let's just leave it as a surd. That's okay with me. Just so we're double checking, this was 7.5. That's where the 7.5 came from. And this is going to be pi times by the radius, which we know is 15 now, and the slanted height, which is this. So I'm going to times the slanted height by 15 and by pi, and that is going to give me my curved surface area, which is 790, and that will be centimeters squared to 3 significant figures. And that is bosh. Okay, this looks like a really tricky question. We've got a sphere and we've got a pyramid, and nothing too interesting there. It does say the volume of the sphere though is equal to this. That's going to be useful. So that's going to allow us to find x, and then from there we can obviously work out the total surface area of the pyramid. Okay. So let's start with the sphere, and we know that the volume is 288 pi, and we know that's also equal to the formula for the sphere, which is 4/3 pi r cubed. So straight away the pi's can be divided from both sides. And we can also divide both sides by 4/3. So we can do this, like so. Lovely cube number. So it gives us 216 is equal to r cubed. So r is equal to 6 by cube rooting. But careful though, because r is of course the radius, and they've labelled x as the diameter. So in fact, x is going to be twice r, so x is going to be 12. Okay, right, that's good. Now it says work out the total surface area of the pyramid. Fine. So the first thing we're going to do is we're going to find the base, because that's nice and easy. Go for the easiest thing first. To get as many marks on the board as possible. So the base is just a square. So the base is x times by 2x, which is of course 2x squared. And if x is 12, that's 2 times 12 squared, which is 288. Okay, right, so that is good. Now we've got to do the triangles, which is a bit trickier and is going to involve some 3D Pythagoras. So the O is the center of the base, as it says here. So if I draw a line directly to the midpoint of BC here, and then draw a line from A all the way down to that midpoint, maybe a bit better than that, then I've created myself a right angle triangle, because this will be a right angle because it goes directly down and then along the base, so it's at right angles. I know one side is 5x, that's the height of this triangle, and I know also that because this is the centre and this side is 2x, then it must be 1x to go from here to here. So I can work out this slanted height here, let's just call it L. So L is going to equal, it's the hypotenuse, so it's going to be the square root of x squared, which is 12 because x is 12, plus 5x, so 5x is 60 because again x is 12 squared. Perfect, so let's just confirm that that's 12 because we know that this is now 12, we know this is now 24, and we know this is now 60. Let's just do that, and that is 60, that height. Okay, so let's find out what L is, and let's leave it as a surd to keep my answer as good as possible. So that gives us, okay, so 12 root 26. Now I've done that because if we look at this triangle here, the one at the front, this big green triangle, that's pretty messy, I'm sorry about that. Anyway, that triangle there, we know the base, and now we know the perpendicular height, because the perpendicular height is L. If I was to draw that out in 2D, it would look like this, and we would know the base was 12, and the distance from the top right down to the midpoint is L, which is this 12 root 26. So that green triangle is going to have a area of a half base times height, which is 12 root 26. So we could do that, we could times that 12 root 26 by a half and by 12. And we get 72 root 26. Okay, so let's leave that and save it for later. And now, yes, annoyingly, not all 4 of the triangles are the same. The one I've just done is the same as the one at the back, but the ones on the side are going to be different. And that's because if I was to do the same trick, the distance directly down across is not going to be 12. This is going to be half of this side, which is 6. So that's going to be 6 there. So therefore, the slanted height is going to be different. So let's call this L2, and that one L1. So L2 will be the square root of 6 squared plus 60 squared, which will be 6 root 101. Okay. That's equal to 6 root 101. So the area of this yellow triangle, that looks like this, is going to be base, which is, so this yellow triangle is going to be base, a half base, and the base is, how many times do I say base, times a half times 24 multiplied by L2, which is 6 root 101. This question's so hard. Times it by a half, times it by 24, so we get 72 root 101. Okay, and now to bring it all together, the total surface area will be the base, which we've worked out as 288, plus I need 2 of the green triangles, which will be 2 times by 72 root 26. And I need 2 of the yellow triangles, because again there's one on this side as well. So that will be plus 2 lots of 72 root 101. And I'll type that into my calculator. And it's gone into the calculator, and it's going to be 2469.4. And it says correct to the nearest centimetres squared, so that is 2469 centimetres squared. Wow, what a question. We have a solid is made from a cone and a hemisphere. Bloody, blah, that's all good. And it just says that they are both 20 centimetres, just like it is on the diagram. It says the curved surface area of the cone is given as this, and then basically find the volume of the solid, so the whole thing. So the curved surface area of the cone, right? I understand. So we're going to need. This is the height of the cone. Obviously, the cone is on its side, but this is still the perpendicular height, and 20 is the radius. And therefore, this distance here is the slanted height L, and the curved surface area, which we're told is 580 pi, is equal to pi RL, as given in the formula book. So we can divide through by pi, and we can write this as 580 is equal to R, which is 20 times by L. So dividing both sides by 20 gives you that L is equal to 29. We can then use Pythagoras' theorem. So L is the hypotenuse. So if I want to find the short side, H, I'd have to do the square root of L squared minus 20 squared, and L we've just worked out is 29. So we could do that. I've got a feeling that is actually a Pythagorean triple, but I don't know. 21, yes it is, nice. Okay, so the height is 21. So now we can work out the volume. So the volume of the cone is given as well. It's a third pi r squared h. So in this case it is a third times by, the r is 20 and the h is 21. So we could do that. Okay, so on my calculator I've just done the bits other than the pi times together. So that's 2800, and that is pi. And then we need the volume of the hemisphere, and the volume of a sphere is 4/3 pi r cubed. So a hemisphere is half of that, so it's not 4/3, it's 2/3. And this will be therefore 2/3 pi multiplied by r, which is also 20 cubed. So we could do that calculation. Okay, we get a less appealing number, 16,000 over 3 pi. So overall, we've just got to add these two together. So the total volume is equal to the cone plus the hemisphere. So if we just add the numbers together, then that will give us how many pies we have. So just add on this, and that must be it then. So that's equal to this number of pi, and we're told that it's equal to k pi. So therefore we can conclude that k must be equal to 24,000. Oh no, that's not quite right, because 24,000 would be divisible by 3. And therefore we wouldn't need to write it as a fraction like that. So 24,403. That works, perfect. Okay, a real corker of a question to finish. So much writing there, reading to do. But essentially you've got this cone, which has the top part of the cone cut off, and that's called a frustrum. And then you've got a sphere which has been chopped in half, and then you've just done a little swap-a-roo. So you've put the small cone on top of half of the sphere, and you've put the top half of the sphere on top of the frustrum. And you're told that the volume of A is 6 times the volume of B. Find an expression for H in terms of K and R. Okay, so let's work out volume A. The frustrum, this part here, is essentially the large cone minus the small cone on top. So the large cone will be a third pi r squared, and r in this case is kr squared, multiplied by the height, which is kh, as it says here. And then we've got to subtract the smaller cone, which is a third pi, and the radius of the smaller cone will be r squared, and the height of the smaller cone will be h. So that's the frustrum part, this part here, the large cone with the small cone on top chopped off. But then we've also got to add on the hemisphere as well in order to make this volume over here. And the hemisphere, well, a sphere is 4/3 pi r cubed. So a hemisphere is 2/3 pi r cubed. And there we go, that is volume A. So what I can do here to try and simplify things is I can take out a factor of a third pi. So if I take out a factor of a third pi of this term, the third pi just goes. I'm left with this thing here. Now when I multiply this out, I'm going to get k squared r squared kh. So k squared times k is k cubed. I've got an r squared and I've got a h. Now over here, when I take out a third pi, I'm just left with r squared h. And here, when I take out a third pi, I've got 2r cubed, so plus 2r cubed. Okay, and now I've spotted that I can also take out an r squared. So this has got k cubed h minus h plus 2r. So I've done some nice factorising there, and I've got volume A in a nice, neat order. So now let's look at volume B. Hopefully this will be a bit more straightforward, because it's just simply the cone, which is missing from the frustrum. That's the bit that got chopped off and got put down here. So that cone is a third pi r squared h, just like what it was over here. And we've also got the hemisphere on the bottom as well, which, again, just like this hemisphere here, was just 2/3 pi r cubed. So I can also take out a third pi r squared out of this volume. So from this term, if I take out a third pi r squared, I'm left with just h. And this one, if I take out a third pi r squared, I'm left with the 2 and an r. So 2r. Okay, that is nice. That is really, really nice. We've got volume A, nice and factorised already. Remember, factors are your friends. So much easier to factorise than it is to expand. And then we've got volume B there. And we know that A is 6 times the size of volume B. Now, there's always a big temptation to times A by 6 here, because it says that A is 6 times bigger. Don't do that. Remember, this is an equation, and it means that A, which is this one, is equal to 6 times the other one, B, 6 times B, which is going to look like this. Just about enough space. Okay, so we've got A, which is this, is 6 times B, which is this. Lovely. And that factorising has really helped now, because we can divide through by that common factor of 1/3 pi r squared on both sides. Lovely. So we just have k cubed h minus h plus 2r is equal to 6 times that other bracket, so 6h plus 12r. Excuse me. We need to make an expression for h, so I'm going to put all my h's onto one side, all of the other things onto the other. So this h I'm going to subtract over, so it becomes k cubed h. I've got a minus h, and I'm taking away 6h, so that's minus 7h, and then the 2r is going to come over, take that away, it's going to give me 10r over there. If I want to make h the subject, I'm going to have to take out a factor of h here, in order so that I can divide through. So I get this. And the final step is to make h the subject, so I'm going to divide through by k cubed minus 7. And that is it. Real beast of a question there. And just for clarity, it says down the bottom here, just maybe to confuse us, I don't know, but that k is greater than the cube root of 7. And the reason why that is just so the denominator is not 0, and it means also that h is positive, because the denominator is positive. So it's just, I don't know, it's just like a caveat. We don't need it for the question at all. Okay, I hope you enjoyed that. Bye for now.